Welcome to the 4D RayTracer project, created by Lucas, Bruce, and Lewis. First, let's have a look at the 3D features. We have physically based shading with both direct illumination from the sun and indirect illumination. Indirect illumination is the light coming from the environment. It is calculated by sending a ray in every direction in a hemisphere to see how much light is hitting the object. Because this process would take far too long to calculate in a single draw call, we spread out the calculations over many frames, iterating on the previous frame to get a better result. Our material system allows us to load many different kinds of materials, such as a rusty material, or a plaster material. Our model system allows us to load all kinds of meshes, so larger meshes may be a little laggy.
Now prepare yourselves as we enter the fourth dimension. Technically speaking, we can never be in more than one 3D slice at any given time, because we are three-dimensional beings, hence we only exist in 3 dimensions. However, using our application, you can view different 3D slices of this object here at any time you want to, and just pop in one, pop out of the other. Simple as that. But if we take different slices at different rotations, that's when things get interesting. We can see here that part of this shape, called the pentachron, is kind of folding around itself. Things just appearing and disappearing at will out of nowhere. It's not really disappearing though. It's moving into a different slice that we can't see because we're only looking at one of them at any given time, because we are still 3D beings living in a 4D world in this application. However, we can go into those other slices and see what they look like. Here, the pentachron gets smaller the further you go into the fourth dimension, and the more you come back to the center, I should say, it seems to enlarge. And along the way, it chooses to, well, it doesn't choose, but it seems to pick some just arbitrary points in space and shrink until that point and then disappear, and then appear from some other point and then enlarge from there. Just morphing along the way. It's kind of crazy. That was just one rotation at a time. How about all 3 at once, plus the slicing? Things start to get pretty complicated pretty quickly, as all the rotations begin to interweave with each other, but it's still somewhat understandable. Like, sometimes there's just 4 triangles and it's a regular tetrahedron. Other times, there's like a kink in it, and then there's like a quadrilateral as like 3 different faces. There's just like a really thin, tiny slice. Sometimes it's a triangular prism. It just morphs the entire time into different shapes constantly, and it's kind of hard to follow, but eventually you kind of get a little bit of intuition for it. Let's take a step back here and look at a different shape. This is the hexadecahedron, which is the 4D equivalent of the 3D octahedron, and all of its slices, when there are no rotations applied, are just an octahedron at a different scale. Just like the pentachron was a different tetrahedron at different scales. There is some similarities between these 2 models. But as we begin to rotate the hexadecahedron, we begin to realize that it is not really like the pentachron anymore. There's some vertices that it seems to pulsate around almost, and if we rotate about a different axis, it seems to change which vertices it pulsates around. And that pulsating action is actually just different faces coming into our 3D slice and, I guess, merging with the 3D slice we already see here. And then it kind of overlaps some of the triangles and then just goes back into where it was before. And speaking of the hexadecahedron's faces, it actually happens to have 16 of them compared to the pentachron's 5. It's kind of cool. Like, if we start rotating around this, we can see that the faces are just all quadrilaterals and triangles as per normal, but the triangles around, like, there's some quads and triangles around a central triangle here, which we didn't have before. And then if we go to the other side of the hexadecahedron, we can see it also happens there too. It's kind of like a mirror image almost, except if we don't have the perfect rotations, it won't be an exact mirror. Um, it kind of also looks like that slicing thing we were doing with the pentachron, where it's just like cutting through the octahedron instead here. Let's make it a little bit less understandable now. How about another hexadecahedron above the other one we already had? It's interesting to me because they're not being sliced at like the same way, even though they have the same rotations in the same plane. But it's because of the translation offset of the other one. But that's enough mind-bogglingness for one day. Let's continue on to the next part of the tech demo.
So the Qt IDE we used to create this project gave us an application framework with a wide variety of free graphical tools for creating a user interface, which are called widgets. And they're these things you see here, these like labels and buttons and sliders. And to create a user interface, Qt allows us to generate a pre-made designing template that can then be linked with a class of the same name. And that template can then be filled with whatever widgets one wants. And these widgets are structured with a hierarchy of parents and children, which is relatively straightforward. For instance, the main window here is the widget that holds all of the other widgets and is the unique parent of all of them. So on the left, it holds this viewport widget here, I believe. And on the right, it holds this grid layout sort of widget, which holds this tab widget and frame widget. And these widgets, their ability to be interactive is based on this signals and slots mechanism. So when an event occurs, for example, if I click on this checkbox, a signal is emitted, which calls a specific slot, or in other words, a function, which then does whatever that checkbox is supposed to do, which is, iteratively render here. And the Qt system is also pretty well documented, which really speeds up the already time-consuming process of looking through an API and finding the function one wants to maybe, truncate this file path so that looks nice. And yeah, that's it.